Hello and welcome to this electrical domain session as part of the buildingSMART International Standards Summit, Valencia 2024. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled Electrical Domain Update and Concept Tech Box, Mastering Complexity of Electrical Engineering with Streamlined Clustering in IFC. The speakers for this session are Bertrand and Bernd Gmeiner. This session is scheduled to last 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speaker, I would like to remind you that this is a hybrid event. For online attendees, your microphone will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand or use a microphone. I would like to bring to attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Bertrand.
Thank you for being here. So this session will be in two parts. I will first give a general introduction about the ambition of the electrical room and what we want, electrical domain, sorry, we're not anymore room. And then I will hand over to Bernd, who will be much more technical, looking at this tech box concept. So the division that we have in the electrical domain is that we think that we have the opportunity to do more in the electrical domain within the BIM and the open BIM ecosystem. And the ambition is to enrich and leverage what is possible today, the IFC, the IDS, so that we can cover what is needed for electrical staff. So it's a kind of twofold ambition. On one hand, we want to bring more electricity in the open BIM, and on the other hand, we want to bring more electrical players to dance with the open BIM tools. The scope that we are addressing here, because electricity is very wide, it goes from the power generation to the socket. So the scope we start with is every electrical staff that is within the building, fitted, attached to the building. So basically it's below the transmission and distribution, below the counter, down to the socket, and it can have PV panels, main switchboard, the cables, the lights, and all the stuff. Of course, with all the different systems, would it be low voltage, essentially, but also medium voltage circuits. This I already said. So the methodology that we use is use case. The reason for that is for enriching the IFC and the rest. We first made an assessment, and there are a lot of things to be done. There are many electrical objects. Some electrical objects or concepts already are in the IFC. Some are not. Some are complete, but most of them are incomplete. So we need a full assessment for that. And facing this complexity, we thought that the best way was to go pragmatically by selecting use cases, investigating the use cases, and for each use cases to use the IDS and the IFC, publish them, and see how we can enrich. So that's what I will illustrate in the next presentation. I go quick on that because it's more important to say what we have done. So the first thing we did was to build a workflow map. So it's a big map. It's here. It's on the one page, but if you want to read it, it should be printed on 3 or 4 A0 staff. So we identified the different phases of the electrical design phases, from early design to operation. In the horizontal colors, you have the different players, the guys we would like to bring in the BIM ecosystem. Some are already there. The architect, of course, the general contractor, of course, but I didn't meet during these days many electrical contractors. I didn't meet many panel builders. I didn't meet any system integrators. And there are players here, and each of them are contributing to build the electrical installation. And so the first objective was to really identify the phases, the personas, the actions that each persona is doing and when, and what tool they are using. This to be able, in the next, too fast, to say, okay, here we have a use case. And basically, a use case is a sensitive touch point where there is a change of face or a change of persona or a change of software so that we can exchange information. So on the principle, if I zoom to a use case, we may have here different use case where the PB, so that's a panel builder, have done a switchboard, and or at the early phase on the left-hand side, or later after the operation, after the build in the right-hand side. The question is where and how the as-built switchboard can be brought back into the BIM model. So this first use case is focused on one object, the switchboard, is focused on, or not focused, is having a big 3D modeling impact. It can be also the second step of an earlier stage where during the early phase, this panel has been estimated for clash detection, or later on, the as-built. So that can be a use case. For each use case, and I will use a what's up here? There is one slide missing. Never mind. For each use case, we want to formulate that use case as a user story, like we do in software development. For example, another use case which is absolutely not 3D oriented is, I am an electrical engineer. I have sized my network and calculated all the short circuit, voltage drop, all this kind of electrical stuff, and I need to draw a single line diagram. I use one tool on one hand, and I have another tool to draw my single line diagram. How do I share information? What are the different kind of objects? So that I don't have to start again from scratch saying, okay, that's a transformer, that's a circuit breaker, I use this symbol. It's not so much part of the BIM, if I say BIM as a 3D modeling, but a transformer is taking some room, some space in the building. The cables are run in the building. I need to know the length of the cable to calculate that, so it has some interaction. That's another use case. This to say that, or to illustrate the fact that one of the specificity of the electrical stuff is that if we ask an electrical engineer to draw a building, he will not draw walls and windows and things like that. He will draw electrical symbols and lines. And we have to bring this into the BIM model. Back to our example of the switchboard. At the end of the construction, these have been very much detailed, in that case using, for example, a NIPLAN software. The question is, what is the object that will be brought back into the BIM model? Do we need to have all this kind of detail, or just a box with the essential information, door openings, operation perimeters, safety perimeters? Absolutely. So we need to go through listing the properties for a level of information or level of geometry that we need, and making sure that we can find this property or in the IFC property set, if not somewhere else. And the somewhere else will be in the BSDD, coming from other classification or as user-defined property set. So this is what we are doing, mapping this. For example, in this case of switchboard, there are some other initiative, like there is one in the IEC standardization to define this kind of properties. So we have to coordinate so that we can be aligned with what the IEC is doing. This to be able to put these properties into an IDS here in this example. So that's not anymore a low voltage switchboard. As you can see, for the specialists, it's a medium voltage switchboard in that case, for the one who are experts. But to say, here are the properties we need to see at the end for this switchboard when it will be delivered from the panel builder back to the BIM model. But as we said, the electrical installation is everywhere in the building. So we need to find a way to describe the complete system, covering all the building, including the transformer, the cable, the switchboard down to the socket, or to narrow down to another system, which can be the switchboard, and inside of the switchboard to give the different subsystem or components and link them to the circuit, because in my switchboard, one outgoer is a circuit that goes with a cable down to the socket, the light, the boiler, whatever. And that's where the tech box is potentially the promising solution. And I give the floor to Bernd.
Thank you, Bertrand. So then, is it the same slide deck? Yeah. Okay. So as Bertrand described how we approach the use case topic, this is of course also, comes with a lot of complexity. As we talk about different roles and different phases with demand for different information and geometry and so on. And so the approach to, even if I have a more or less a technical presentation now, I want to show a way how to deal with that complexity and make it really easier to cope with that. And that's a concept we call tech box. And it's kind of streamlining through intelligent clustering of information towards the use cases. Just some history about the tech box. So it originated 2019 in a joint working group between buildingSMART Germany and Egnaton. So it was focused on laboratories. And it was in the beginning just kind of a collision body, so that you have kind of a an object that you can place within a model if you don't know yet the exact object that will be in that space later, but you still need something to calculate with and to put information to it. And why is that important? Because if you want to collaborate between different trades, so even within the MEP trades, so electrical, HVAC, fire safety, whatever, there are a lot of things that need to coordinate. And doing that through a single specific physical object may be sometimes difficult. That's also a reason why we invented the tech box, but we did not really invent it, but I come to that. It's better than that because it really bases on a very important standard. And so the idea is that the transition between the operational phases is seamless. So we are not talking only about planning, we are also talking about the whole life cycle process for a project, also operation. So as said, it's therefore to structure the models, the information within the models, and so on in a better way. And it's not important if it's 2D, just metadata, 3D, or whatever. And of course, we also want to use the LOIN concept properly for buildingSMART, so that the level of information need is specific to each use case. Just that you see how that looks like. That came originally from the laboratories. So we have a tech box for a laboratory workshop part, which consists of several very complicated things, like the fume hood in the middle. And as you can see on top, it has where the air duct is, where the outlet of the air duct is. So you have this red ring, for example, for HVAC. And this is an important thing because it's kind of an interface between two objects, two tenders. So even if in an early stage, you already know what the volume flow will be, what the diameter of the air duct will be, and so on, but you don't know yet what the supplier will be for the fume hood, and so on and so on. So if you really can position that interface within a room in a very early stage, you can plan a complete level of the building just with this tech boxes, and have already the properties you will need later on the right position eventually. And so you can do your calculation very early in the process. So that was originally the idea. And as you can see on the right bottom, it doesn't mean that the tech box itself develops its geometry. No, it's just, as said in the beginning, an information container, and you attach the 3D object later to that, so it can develop in level of geometry later on, step by step. And of course, this can be done for electrical domain in the same way. It's just a little more complex, but also makes life easier. So we are talking in our room here, or electrical domain, about medium voltage and low voltage within a building. So that's our restriction we set for our room. And as you can see, what I said before with the example of the laboratories, it's the same here. For example, if you have a distribution board in the middle, there are a lot of other disciplines connected to it, like HVAC, lighting, and so on and so on. And it's a good thing that you have kind of a way that supports a connection, even if all the objects are not defined yet in detail. And as I said, the tech box is just a concept we invented at some point, but it is based on something that exists before, or the ideas exist before, so that you have in the ISO 19650 something that's called federation strategy. What's the idea behind that? So if you have objects that intersect each other, sometimes that's difficult to cope with in some cases, I think. So if something goes through a wall, for example, in another room, but still the object itself would be great to have kind of information container for it. And the term information container is very important for that, because if you go in detail, what says the ISO 19650, so you have kind of information containers for architecture information, for MEP or engineering, and within MEP, as you can see, you also can divide that into mechanical, electrical, and plumbing. And that's the basic concept behind that. So what is an information container in context of a text box? It can be just metadata, it can be 2D data, documentation, or it can also include 3D models. That's the idea. So you're not restricted to a geometry for a text box entity, if you like. And what Bertrand already said before, so it's very important that this concept is aligned with our approach to work on use cases. So in the beginning in our domain, we had the idea to just collect as many information as possible, exchange requirements, write them down in Excel tables and so on and so on. But very quickly you saw that's maybe a little bit too much, because you come up with information you might need or might not need, and that's the problem. And that's why we said, okay, we need to specify use cases so that we don't hallucinate some information no one needs, and really restrict that to the really necessary information you need. And that's how we described the use cases. Bertrand already showed the big map. So it's called a BPMN, a business process model and notation. That's how we described our complete processes between, for all roles in all phases. And also the use case descriptions we are doing. And here again, I think you also showed that they are the roles and phases. You can look that up later. It's just, you can see it. And as Bertrand also showed, so we cut out a piece of the process map, define a role. And the important thing here is that the information is homogeneous between the sender of the information and the recipient. Otherwise, it's difficult, to describe exchange requirements if you have software that need different kind of geometric details or something like that. That's not going to happen. So that's the reason why we did that. And now back to the text box. Why is the text box important in that context? Because you don't attach the information that is exchanged between two objects, which you need, for example, for calculation in a very early stage. You don't attach that directly to the object, the physical object, but to the text box information container around it. But I come to that. That was the last sessions we had about this. It was just a theory or very theoretic how to do that. And in this session, we come to how we do it in IFC, how this is done, how this can actually work. And here again, so we have different levels of text box entities, if you like, for our domain. So the highest one is solution. Then we have, so which would be the complete building electrical network. You need to somehow start defining in an early stage. The systems are, for example, the switch boards. Subsystems are the cabinets, components, and so on. So that's, for example, for a solution, so that you see a whole building, how everything is connected within the building. So that's what you would put into a solution information container or text box. The system, as you can see, is the switch cabinet itself. But now I want to dive into the real details. So let's put some information in there. How does that work? So you have the text box system, which is the distribution board. And as you can see in IFC, everything we need is already in IFC. So we don't make up something new. It's already in there. So we decided or we propose to use the class IFC element assembly, which can have geometric data but doesn't have to. But in this case, it's LOG 100 if you like to put it into geometric levels. And And then we said, okay, we need to give that a name so that you know, okay, we are talking about the TechBox system. So you can have everything is there. So the abstract class IFC type object, element assembly type, and then and that's the important part. So we have our own P set. So we call it elec P set. So it's allowed to create your own P sets if you like, even if they are not in the IFC standard. Yet, but therefore we also have the BSDD where you can upload your own P sets if it makes sense, and that's what we, for example, would do for the elec P set for the electrical tech box, if you like. And here comes this what I said in the beginning. What is this interface information? For example, for I don't know if you have seen it, but in the right bottom of the tech box on the right side, there's something popping up. So it's more or less a electrical outlet. You may still know in the beginning that this is a IFC distribution port. You can add some properties to that, even if you don't have the physical object in the tech box. Then, of course, you need some clearance spaces. So you say, okay, there needs to be some distance to the roof, the sides, and so on, also for the doors. Yeah, there's also something in IFC. In this case, we choose for us IFC spatial zone, which is then connected to the tech box, to the element assembly. And the good thing is that you can also create, or we propose to create, a P set for the clearances. So you have a clearance for transport, for operation, for maintenance. So because I think it really depends on the role and on the purpose. So if you add or attach the clearance spaces you need, for example, for a switchboard for everything, then maybe it's not really helpful for the people who are responsible for the transport. So that you know, okay, we can put that into the building, or no, the doors are not high enough. So with the the wooden transport pallet below it will not work. So it makes sense to have kind of a clearance space for transport. And with the tech box approach, it's easy, to distinguish them and create separate ones. Then once you know who will be the supplier, for example, or you need what what the physical object will be, then yeah, just attach it. And the good thing is you already know there are this distribution port details. So you can fit the object you add to the already defined, in the process defined properties for the connection port. And that's how this works. And then if you go more into detail, then we found that, okay, in electrical, especially in electrical, there are a lot of missing properties we need. There's two possibilities. One is to find all the property sets already existing, maybe 10 for a switchboard you need, and then you need one property per P set. I mean, you can do that, but it's also possible to create what we did in that case for a use case specific electrical P set property set for the switchboard. And then you can attach that directly to the physical object. But the information you need to the connection to other objects, tenders or systems will be in the distribution port. And if you go into a subsystem, which is a cabinet in that case, you also, of course, start with the system, because it needs to live somewhere. And then you, which is also already given in IFC, the IFC relation aggregates class. So you attach it in a hierarchy into the bigger tech box, if you like. So as you see, there are no physical objects yet in there, but still you can use the exchange, the exchange properties between other objects to do that. And then later on, you can just add the physical objects. And of course, you can also add this clearance space to a subsystem. So you're really free to do what you like with that approach, and you're very flexible also to exchange physical objects, because their requirements are still there connected to the tech box. Then of course you can go down to the components, you can go down to the products, works the same way. And for the whole system with its hierarchy, you can easily show that with just a tech box approach. So you have even before you know the real objects, you can define all the properties you need for the interfaces. And also you can connect it to the whole system. So everything will be in the presentation slide. So it's very small, but if you download them, I think it's easier to see them. So what I'm saying is there is a IFC class for everything. We didn't invent anything new. We just reuse what is already there. And why is this tech box approach in addition for the electrical domain so important? Yeah, because as you can see here, if you have a single line diagram, you can also see, for example, these yellow boxes around the connection points are the tech box systems. So you see, okay, there's this distribution board. You see where it lives in the single line diagram. Provided, of course, the software showing that single line diagram knows how to read that. But as it's IFC and we propose this properties to be in there, a software would be able to read that and also show where the tech boxes live inside a single line diagram. And you can also do that with connections. So sometimes the term box may be a little bit misleading, but as said, it's a information container. So, and it's there for also showing functions, for example, that are not physical within one thing, but it like bus bar system. They just go through something, for example, but still you can use that approach to address that. For example, for a whole bigger picture of a system. So you have consumers like the motors, or they are connected via electrical connections and data connections to a distribution system, and so on and so on. So you can really easily visualize that and also do it logically. You integrate it logically into a information container. And then just the last part I want to show you quickly is you also mentioned, Bertrand, we want to use the IDS, the information delivery specification for our work we're doing in our domain. Makes sense in that sense that, as said, if you want to have exchange requirements for a specific role in a specific phase, to interconnect with another role and in a specific phase, you need to align somehow what is the information you want to exchange, and that can be done with the use cases. And as a result of the use case, we propose to create an IDS for relevant use cases, even if there are many of them, no problem. But then if you know that there is an IDS for a specific task you have to do in the electrical domain, you look it up. Maybe it lives somewhere in the UCM. There's some discussion about that, where to put the IDSs. But then you have kind of a template. So you say, okay, if a project starts, then you have the exchange information requirement in the beginning, where you define what will happen or should happen in the project. And there you can already define, okay, we have to use the IDS1 and IDS2, which is a representation of all the information we define for a use case, but not the all the optional information, really that's just necessary information. And then, for example, if an architect creates a first IFC file based on this IDS, so he knows, okay, I need to put in a special kind of wall or a special material and so on and so on. So this would be in this IDS. And then the IFC file would also include that. And then in the next step, maybe the architect and the planner work together, and then some new IFC files will be created. So they develop. So that's why it's called IFC file 1.1. So but it's still, and that's why the S is next to it. It still needs to fulfill the requirements of the IDS. We can verify that. There are a lot of good software for that to do that. So you can verify if you're still on track. For the IFC file 2, you use the other IDS, of course, and it's not mandatory only if it's set, of course, from the investor in the beginning of the project. But I mean, it supports the process. You're not forced to use the IDS. So there's also an IFC file 3, which maybe is just made without a template. Yeah, and then when it comes to the end of the project, then what's going to happen? Class detection, of course, and verification, and that's where you also use the IDSs then, which developed or evolved out of the use cases we are doing. And that's the way we envision using IDS. In connection with the use cases we are providing, or we are starting to provide, and also how the tech box is involved in all that. So was my last slide. So we are open for discussion, question, criticism, everything is welcome. Please.
So a great presentation, thank you. One question about things that say you're reusing IFC and what's in there, and you've also shown that you have for instance, an electrical IFC file and an architectural. And these tech boxes, they can have multiple distribution ports, also from other domains. So it could be a HVAC thing, it could be a plumbing thing, an electrical thing, etc. But if these other MEP disciplines resides in other IFC files, then you will have a reference from, for instance, the ventilation thing to the port in the electrical tech box. And that's an external reference, which I think is not yet supported, or at least not documented how to be supported in IFC. So have you discussed this with? Yeah.
Okay, that's a good point. What I didn't show in the slides, because maybe they would have been too technical then, of course, these lines you were seeing in between these entities, for example, for the IFC element assembly towards the IFC distribution board, there are, of course, some relations which already exist in IFC, and they are inverse relations. So the object does not really know with what it's connected. There are this inverse relations, so that points, for example, from the cabinet to from the distribution board towards the tech box, the element assembly, and to something else. And there's no problem. For example, you have IFC rail nests, or you have so many different relations. You can just draw a relation from another object, another domain, to that kind of tech box. And also you can relate that to, or you can tag it, if you like, with the domain you're working in. So if this is something from fire safety, it's no problem. You can also connect it to this tech box. And that's, I don't know if that answers your question, but yesterday there was a question raised that said, if you have a collaboration model and we have different traits from, for example, from fire safety, we have a model, architectural model, we have a electrical model, and they live in the same space, and then you want to coordinate that, and you open that all in your software, could be a problem, because how do you do class detection if the IFC files are not really good connected? But with the relations, that's possible. That's also a reason for the tech box. I don't know if that answers your question, or.
Yeah, I'm just saying that when you have a self-contained IFC file for a specific domain, and that relates to objects and especially distribution ports, then resides another IFC file, totally independent. There needs to be just a clear guide for how to implement that.
Yes.
So it's the same, and that's what I'm saying. I'm not saying it's impossible. I'm just saying it really is a key thing. So these MEP is not one domain; it's many domains. And many specialists working with a specialized software, and this needs to be kind of connected somehow. But even if it's separate IFC files, yes, they can be combined, but it should connect when you combine them. That's what I'm saying.
Yeah, you're right.
Yeah, it's basically just an implementers agreement. So software implementers agree, this is how we do that thing. And this is missing up to now in IFC.
Yeah,
so that was my question and my comment. Thank you.
And this is really why we have selected a use case approach, because as you pointed out, there are so many different situations that if we want to embrace it at once, it will be very complex. And we know that already focusing on just the electrical power distribution, we must make sure that we have all the objects that we want. Take an example, in IFC, you can find an IFC protective device. Is it enough for us electricians to say this protective device, is it an MCB, an ACB, an MCCB, an RCBO, a switch, a fuse switch? So there is all this taxonomy of electrical animals, I call them, that we need to list and to do and make sure we can find them. Same, starting with the electrical distribution port we saw, it depends when we are. If you just need a single line diagram, okay, you say that's the upstream device, that's the downstream device, done. But then later on you say, oh no, this one is on the phase 1 and this one is on the phase 2, and I want to manage my phase balancing, and we need to have this. So can we do it? Can we not do it? There will be a use case for that. And to the control, it will be the same. Sometimes the control will be from an impulse push button, because it's a corridor and you have an impulse push button going to the switchboard. Sometimes it will be a backnet signal. Sometimes it will be a KNX signal. Sometimes it will be, and we must make all this investigation progressively, one by one. And one of our best benchmark is what you did in DDA SCAD. That's we are used.
Yeah, thanks for the presentation. My question is, when it goes down further to the product level, even if we know who the supplier will be, how does TechBox connect to the digital product passport, which will be mandatory soon? Because all the data is already in the digital product passport, and we need to connect this somehow. Will this be, is this a concept, or?
I mean, there are two things or two possibilities to do that. And that, of course, needs to be discussed. If this passport is neutral for the supplier, so you need a supplier that can fulfill that, you could theoretically put it into this interface requirement, so that anything you dock on there needs, once you make the connection, you have kind of not a clash detection, but verification. Oh, okay, this will not work because this supplier doesn't support that. Or you could put it directly onto the, but that's then not part of the TechBox concept. You could directly demand that you would put such an information on the, for example, the distribution board itself as object, but that needs to be defined. I think it could work both ways, but if you, for example, demand this needs to be for the whole market, you put it on this interface, this information. You know?
But here we didn't serve with what you were expecting, I'm sure. If we go to the product, first, if we think about products, there can be product types. We have one type of product, let's say a miniature circuit breaker 16 amps. And I'm sure that a miniature circuit breaker 16 amps, there are 200 or 400 in a building like this one. So then the product type has many instances. And here for the digital product passport, we have a passport for the product type, but then a product passport for each instance that only comes the day it is installed. When there is a QR code, you can scan and say, this is this device with this manufacturing date, blah, 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 blah. So here, I think we have to look a little bit outside of the BIM domain, what is going on, and they're going to the industry. And in the industry, as you know, there is the asset administration shell that seems to be the best solution for that. No need to embark the solution, but say, I describe the information about this device and say, you want to access the digital product passport, here is the URL address or whatever, and you will find all the things you will have. And this kind of concept of asset administration shell, difficult to pronounce for me, can be applied to a product, to a system, subsystem, or whatever, which should have this kind of description capacity for a switchboard or for a complete circuit, which is another way to see the system, or for a product or for the complete installation. Did I answer well?
So electrical domain, it drives everything, almost everything. So there's a lot of things that needs electricity or have sensors or whatever. So let's say a revolving door, okay? So the position is defined by the architect or whatever, but it needs to be supplied with power, and there's some sensors and there's some locking mechanisms, all of that stuff, electrical domain. Are we considering then a revolving door as a tech box from electrical domain point of view, but position and everything else is owned by the architect? Or how do we handle this thing? It's all old stuff. It's even in a toilet with heated seats and whatever, sensors and all of that. So how do we connect with the other domains that actually owns the responsibility for positioning and which space it belongs to and all of that stuff?
Yeah, that's a good point. As said, the tech box approach started in the lab and is still developed there. Now it's also in the electrical domain. There's also another domain about open BIM in industrial planning that's using that. At some point, these domains have to talk to each other. You're completely right. And that's also, I mean, kind of a question to the market. Hey, take part in this discussion, because it can solve a lot of problems we're facing now with interaction between domains. Of course, there need to be discussion and some alignment on that.
Yeah, thank you. So, but again, so if an object placed by an architect contained an electrical tech box, so to speak, with a couple of distribution ports or whatever, that would be sufficient. And then we can connect to it quite easily. But that has to be aligned, as you just said. We really have to align with the other domains, because I think electrical domain is probably the one that connects to most other things, where the things themselves are owned by someone else, or placed at least by someone else. So, okay, thank you.
There is. Sorry, maybe Bernd will smash me when I answer that, but the way I see the tech box is not anything new. As we could see, the tech box is leveraging what is possible in the IFC and bringing eventually some additional electrical tech box piece set, that is the properties that are not either in the IFC or anywhere that we need, and bring them, but use the IFC capabilities in a certain combination. But it's not a specific electrical tech box. It will be an IFC element, blah, 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 an IFC object, blah, 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 etc., etc.
Yeah, that's right, Bertrand. For example, I mentioned open BIM in industrial planning. For example, they don't use it sometimes not as IFC spatial zone. They use IFC space, for example, because they want to describe an area where, for example, a robot is working and you don't want to pass because maybe you die because the robot is very fast and it's just doing its job, you know. So you need a IFC space to say, okay, that's dangerous. So of course you can do the class detection. So you should not put, for example, emergency washing eye washer in this space because maybe the eyes aren't the only problem then you have. So that's the reason why, as you said, Bertrand, it really depends on the domain. We said for us that IFC element assembly and IFC spatial zone works good for us. But another domain, maybe use also other already existing IFC entities. That's no problem. Okay, then if there are no more questions. So thank you so much from Bertrand and myself for your attention and your questions, and yeah. And feel free to contact us if you have more questions or want to have some details. As you can see, this stuff is available on the open license, so just download it. Okay.